Alright, today we're going to be learning about simplifying rational expressions. These are a little bit more complex than what we've seen in the past. Our steps in general are to completely factor all the numerators and denominators if possible. This includes any type of factoring that we've seen. We're going to cancel only factors that are exactly the same. We're not canceling pieces of binomials or trinomials, okay? And then the last thing we're going to do is we're going to make sure we state our restrictions. That is what values are not in the domain. And we're going to set any denominator factors equal to 0 and solve in order to do this. And the big thing here is that we need to make sure that we're solving for the first variable alphabetically. So here is our first example. We need to keep in mind here that any type of our factoring can show up. So we're going to simplify the rational expression and state the restriction on the domain. This is what we're going to be doing for every single one of these examples today. So when we go to factor the numerator x cubed plus 8, that, remember, is a sum of cubes. Okay, a sum of cubes. And so to factor that sum of cubes, we take the cube root of the first thing. So the cube root of x cubed is x. Since it's a sum of cubes, we're going to put a plus sign there. And then the cube root of the second thing, the cube root of 8 is 2. In our bigger parenthesis, we take the cube, we square the first thing. That gives us x squared. We multiply the two things together and switch the sign. So minus 2x. And square the second thing, which would be plus 4. In the denominator, we have a difference of squares, and we've seen those way more often. So x squared minus 4 would factor into x plus 2 and x minus 2. Once everything's completely factored, we're going to cross off factors that are the same. So these are both the exact same thing in the parentheses, so we're able to cross those off. So the first part of our answer, we are left with x squared minus 2x plus 4 over x minus 2. The numerator is a trinomial and the denominator is a binomial, so we can't cross off parts here. We can't simplify any other pieces of this, so that's the first part of our answer. The second part is to find restrictions, and in order to find restrictions, we need to set any of the denominator pieces equal to 0. So if we set x plus 2 equal to 0, that would tell us that x can't equal negative 2. And if we set x minus 2 equal to 0, we would get positive 2. So x can't equal positive or negative 2 are the restrictions for that example. Alright, again, we're going to do the same thing. Here we just have different types of factoring that can show up. So here in the numerator, when we have 4 terms, we are going to factor that by grouping. Okay, so I'm actually going to do the work over here of factoring that so that we can kind of keep track of things. So when we're factored by grouping, we are going to split the question directly in half and find the GCF of each half. So looking at the first half of this, the GCF of x cubed plus 3x squared would be x squared, and left inside would be x plus 3. Taking the GCF of the second half, negative 9x minus 27, we would bring out a negative 9, and left inside is x plus 3. The way that we know that we're correct here, remember, is that those parentheses are exactly the same. So we're going to write that part once. And the GCF parts are going to come together to give us our other factor. Now from here we need to see if anything else can factor more than this. So we're going to factor this, leave the x plus 3 alone. X squared minus 9 is a difference of squares, and that would factor into x plus 3 and x minus 3. So we already had one x plus 3 here. We have another one, and we have an x minus 3. Okay, so that is as factored as that numerator can get. So I'm going to carry that over here in our question. And in the denominator, x squared plus 6x plus 9, that is going to factor into x plus 3 squared. You can choose to write your restrictions at this point, or you can write them later on after you've simplified. So let's go ahead and simplify. We have x plus 3 squared, which means we have 2x plus 3's in the numerator. We have the same thing in the denominator. So those x plus 3's both go away in both the numerator and denominator. And we're left with just x minus 3 as the first part of our answer. For the second part of the answer, we do need to write our restrictions. Remember, when we're simplifying, we're only looking in the denominator after we've factored it, but before we've crossed things off. So that x plus 3 would produce the restriction that x can't equal negative 3. Again, the same steps are going to happen over and over again as you're going through these different questions. It's just a matter of what type of factoring is being used for the problem. Alright, let's look at another type of factoring that we have here. This was factoring quantities is what this was. So this numerator is factoring quantities. And that just means we have parentheses. Okay, so we're going to be looking at what those have in common. Alright, so just like we did before, we're going to work over here to factor our numerator. So looking at this, there's only 2 terms in this numerator. That is all one term, and this is a second term. And remember, terms are separated by addition or subtraction signs outside of parentheses. So if we're looking and comparing these 2 terms, we notice that they both have x plus 5 to the third. We could be able to take x plus 5, 3 of those out. And looking at the x minus 3's, we have 2 of those that we could take out. And then we're going to write everything that's left in this. Okay, so everything that's left in this, the 3 would be there. We took out 3x plus 5, so there's going to be 1x plus 5 left in the first term. And that takes care of everything in the first term. In the second term, we're left with the negative 4 or the minus 4. And an x minus 3. Now it's our job to simplify this bracket part as much as possible. So we're going to leave the x plus 5 cubed and the x minus 3 squared. And inside this bracket piece, we distribute the 3 in, so that's 3x plus 15. And we distribute the negative 4 in, so negative 4x plus 12. And then cleaning that up inside the bracket, I'm actually going to make it a parenthesis at this point. We would get negative x plus 27. So remember, parentheses, brackets mean the same thing. Brackets just kind of clean things up so you're not looking at parentheses within parentheses. The last thing that we can do here is we have a negative inside this. So I'm going to bring that negative out as a GCF. And inside this parenthesis then, bringing out that negative is going to change the sign of both of those pieces. So that there is now as factored or as simplified as our numerator can get. So I'm going to bring that over here. And then our denominator is as factored as it's going to get. We can't do anything with that. And so now that we're here, we need to simplify anything that they have in common in the numerator and the denominator. Well, in the numerator, they have 3 x plus 5's. In the denominator, we have 8 of them. So if we were to eliminate the 3 x plus 5's in the top, with 3 in the bottom, 8 minus 3 gives us 5. So we have 5 x plus 5's in the denominator. There's nothing else that simplifies in this question. And so we are going to be left with a negative times the quantity x minus 3 squared times x minus 27 all over x plus 5 to the 5th. So that's the first part of our answer. And the second part is our restrictions. If we set this denominator piece back here equal to 0 and solve, we would say that x can't equal negative 5. So that would be our restriction. All right, moving on, we are going to do this question next. Okay, so both of these are factor by grouping questions. Again, the reason we know that is because there's 4 terms in both the numerator and the denominator. So we're going to show our work of how we're factoring those things over here. So for the numerator, we're going to split it in half. The first half has an x in common, and left-hand side would be 3m plus 4a. The second half of the question is going to have a positive y in common, and left-hand side is 3m plus 4a. Again, parentheses the same, so we're going to write that once. And the x plus y is going to be, the GCF parts are going to go into parentheses together. So our numerator factors into 3m plus 4a and x plus y. And remember, you can put those in the opposite order if you want. Okay, we're going to do the same thing with our denominator here. So splitting it in half, the first half has an x in common. Left-hand side is 3m plus 4a. The second half, this is a negative, so we're going to bring a negative y out as its GCF. And left-hand side, 3m plus 4a. That tells us, again, the same thing in the parentheses. We're going to write that once. And the x minus y comes together in our second parenthesis. So 3m plus 4a, and x minus y is how the denominator factors. Looking at both of these pieces, we notice that the 3m plus 4a in the numerator and the denominator cancel out. So we're left with x plus y over x minus y. Again, you're going to be very tempted to try and cross off these different pieces. They are part of binomials, so you can't cross them off. If it helps you to remember that, put parentheses around them. And if you leave them in parentheses, you should know that you can't cross off anything that's not the same parenthesis. For our restrictions, we're going to show a little bit more work for this off to the side. So if we set this first one equal to 0, 3m plus 4a equals 0. Because there are 2 different variables in this, you're always going to solve for the first one alphabetically. So we're going to solve for a. That means that we should subtract 3m from both sides. And then divide by 4. So a would equal negative 3m over 4. When we go to write our restriction, though, we need to say a can't equal negative 3m over 4. That's because if a were to equal that, it would make this denominator piece 0, which we know we can't have the denominator equal to 0. For the second parenthesis, if we have x minus y equals 0, again, you're solving for the first variable alphabetically. So we're going to add y to both sides to get x by itself. That would tell us that x equals y, so we want x can't equals y. Those would be our 2 restrictions. So this gives you an introduction back into the different types of simplifying rationals that we have seen in the past, different types of factoring, and what to do if there are restrictions that have more than one variable in them.